Okay, cool. Yeah, so thanks for the intro. Yeah, my name is Nader Dabit. I work with AWS on the mobile team, but we're now kind of less of a mobile team and more of like a client team. We build stuff for web developers, mobile developers. A couple of the things that we work on are Amplify and AppSync, also Device Farm. And what I'll be talking about today are a little bit of Amplify and a little bit of AppSync. And the general idea around this talk is really focused around the combination of a front-end technology and GraphQL and how to actually do a lot of interesting things that you may not have thought that you could do with GraphQL. What I'm talking about today is implemented using AppSync, which is an AWS GraphQL as a service, but anything really that I'm doing can be done with Hasura, Apollo, Graph CMS. It can be done with Prisma, essentially any GraphQL backend. So it's not really, only AppSync. I'm just using AppSync because I'm very familiar with it and also work with it on a daily basis. And I'm also going to be working with some Lambda functions. And if you're using AppSync, it just makes it a little easier because you don't have to worry about permissions on your Lambda functions. So when you think about GraphQL, a lot of times people think about interacting with the data source. But what we're seeing now with GraphQL, and as it evolves as a technology and it becomes more and more widely adopted, people are using GraphQL more as like an API gateway for a lot of applications. And a lot of times what they'll do is they'll bring in existing applications in front of or existing backend APIs, REST APIs in front of a GraphQL endpoint and kind of use GraphQL as a single source of entry and kind of port over existing REST endpoints into GraphQL. This way people can kind of get up and running. They can get the benefits of new endpoints that they would create in GraphQL without having to sacrifice a huge rewrite of their existing application. They can also take advantage of the client-side benefits of using GraphQL, having a consistent API gateway. And when you're building GraphQL, a lot of times people think of the resolver layer as being some type of data source. But because GraphQL resolvers are essentially just functions, they're just a way to interact with something. It doesn't have to be a data source. There's actually quite a bit you can do at this level. And we've done some really crazy stuff lately. And I'm kind of going to show off some of the stuff that has come out of some real world use cases working with some clients that we've worked with. Usually what will happen is I'll be working with a customer, helping them solve some problem. And I'll be like, oh, this is really cool. Let me go create an example project that uses this. And then other people can use it and I'll open source it. So essentially I'll see an opportunity to create something. I'll go and create it. And I'll usually go out and find something in the community that someone else has already created and kind of use that as like an entry point. And you'll see that over and over in this talk. So since resolvers are just functions, you can do, again, a lot of interesting stuff. And that's really what this talk is about. So this is Curious Cases of GraphQL. My name is Nader Dabit. I'm Dabit3 on GitHub, Twitter, and Medium. Not only do I work with as a developer advocate on AWS, but I'm also a web and mobile developer of about 9 years, I guess, at this point. I've written a couple of books. One is React Native in Action. The other is Full Stack Serverless from O'Reilly Publications, and it's now available if you're interested in building stuff, with full stack apps with serverless technologies, I guess. I'm also on the React Native Radio podcast, the GraphQL Patterns podcast, and sometimes on the React Roundup podcast. So that's me. Let's go ahead and get to our talk, though. The first demo I'm going to kind of show off is a GraphQL real-time drawing canvas. So the idea here is I saw a tweet from someone at Microsoft that had built something really cool where they were basically kind of doing something similar to this, where they were drawing or they were kind of replicating a drawing across multiple canvases in real time. So I wanted to duplicate that, but I wanted to do it in using GraphQL, but I also wanted to have a way for the strokes to be replicated in the same order which they were drawn. So you could kind of see the drawing happen in real time after someone had already drawn it. So say you pulled this up later and you wanted to know how someone had drawn this. We wanted to kind of map the drawing back to the canvas in the same order which it was created. And then any additional strokes, we wanted to kind of subscribe to those using GraphQL subscriptions. So we're going to walk through how we built this. The first thing I wanted to do is build this on the client, because once the client implementation is done, I could kind of port that over to a backend. And what I ended up finding was this open source project called React Canvas Draw. And React Canvas Draw just allows you to install it using npm, and then you import the Canvas Draw component, and then you can then use that. And then you can also have a bunch of methods that you can pass into Canvas Draw to kind of have more control. You can also have callbacks and things like that, functions that get called as the canvas is drawing. And what I ended up doing was not only did I didn't just install it, I actually forked it and kind of made a few changes locally so I can have a little bit more control over it. And this is kind of what it looks like. If you look at the GitHub repo and you just clone it and run it, you kind of get this. But you essentially have a square canvas, and you can set the canvas to whatever width and height that you like, and then you can just draw on it, and that's kind of about it. So after we found the project we wanted to use for the client, I wanted to then model the data, and I modeled the data based on the implementation of React Canvas Draw, and that data model looks just like this. You have a main object that has 3 properties. It has a width and a height that defines the canvas. And then you have a lines array. And this lines array kind of dictates the different points, the different drawings that are on the canvas. So you have an array of lines. Each line is an object that has a points array. It also has a color for the brush, and it also has a radius for the brush. So you can kind of dynamically change this stuff. You can change the radius of the brush, make it wider, change the color. And then this points array, as you plot all these points on the graph, it basically forms a line. So that's kind of how that works. So that's how the data was modeled. So how are we going to actually port this into GraphQL? Well, what I ended up doing was something pretty simple. I created this GraphQL schema. This schema has a really, really basic single type called a canvas. The only property that we're going to be populating from React Canvas Draw is a stringified version of this lines property, or this data object containing the lines and the width and the height. So that's the data. We basically stringify that. We have an ID to specify the canvas itself, and then we have a client ID to listen for the client that's making the changes, because when you're working with GraphQL, you often will have an optimistic response. And then on the other clients that are listening, you want to have that data come in real time and draw that back to those other clients, but you don't want to redraw locally. So with the client ID, you can kind of like understand who created something and then discard duplicate data as it comes through in a GraphQL subscription. And the operations that we wanted to have a way to create a canvas and update a canvas. And then we wanted to have a way to subscribe to changes on the canvas. So that's kind of the only operations we have. We have a mutation, and we have a subscription. We have 2 mutations and a subscription. So let's take a look at the demo. I know that that image isn't the right use of that meme, so it's all good. Okay, cool. So I'm going to go, actually, let me go back here. And I'm going to open this. This is the demo for React Canvas Draw. So what I'm going to do is I'm going to open another window here. And what I want to do is just copy localhost here. And we see that the drawing gets kind of redrawn. Let's go ahead and clear that out, though. And then we'll go ahead and create maybe one other window. And what we're going to do is we want to draw across the clients. So we're going to go ahead and say R. And then we want to jump over here maybe and say like A, C, D, exclamation point. And we see that this is kind of working. So that's basically it. You know, we're basically listening to a subscription on update. So whenever the canvas updates, we have a new subscription being fired. So I'll jump back to that data model one more time. So right here, the on update canvas, that's a subscription that we're kind of listening for. So now we'll jump to the next I guess, example that we're going to look at. And this is image detection or image recognition. And this is really a combination of two things. This is how do you work with files and images in GraphQL? And then once you're, understand that, like what can you do with that? And one of the ideas that I had was kind of how can you work with AWS services, but not just AWS services, managed services in general using GraphQL. Like how does that even work? So what I wanted to do was have a way to implement some machine learning or artificial intelligence services into a GraphQL API. So the first thing I wanted to do was model the data. That was pretty simple because when you're working with an image, you only need an image URL or like an image key, depending on the image service that you're working with. And what you end up wanting to do is you end up wanting to have a couple of operations that happen when you're working with images with GraphQL typically. There are like two main ways that you can actually work with images. One would be to base encode an image and like store that directly in your database, but that's not the preferred solution. The preferred solution when working with images is to first upload the image to some type of image API or image service, and then you get the return from that call. You'll have a key or a URL that specifies where that image is loaded or where is it saved. And then what you'll do is in your GraphQL schema or your GraphQL API, you'll have a reference to the image location and other metadata. So that's kind of what we did here. And we made the base schema really, really basic. All we really wanted for this was to have a string that has the image data, and the image data would be the return value from our API call. So with what the machine learning or artificial intelligence service that we're using is basically going to return a JSON object with all of the data about that image after we've run it through the image recognition. So that comes back in a string. So we basically stringify that on the server, and then when it comes back on the client, we parse it, and that's kind of how that works. And we have a process image query. This could also be a mutation, whatever. You basically call that, you pass in the image reference. So this would be like the image URL. Everything else happens on the back end. So how does that even work? Well, this is exactly what we ended up doing. It's pretty basic when you actually walk through this. We first have an image upload. So the user uploads an image to the app, right? They basically snap an image or we upload an image. In the background, what we first do is we first store that image in S3. You could store that in whatever image service that you have or an image API. That will then return a key for the reference for that image. We send that key via GraphQL into a Lambda function. The Lambda function then processes the image and basically does all of the work within this Lambda function. And once the Lambda function is finished executing, we then return the value that was processed in that Lambda function. And this is what that Lambda function looks like. This is literally all of the code that just processed everything. We import the recognition library is what we're going to be using from AWS. And in the handler, we have an event. And the event has the GraphQL information, the GraphQL query information that we reference called image info. So we create an image object that has the bucket name and the image URL, and we dictate the attributes that we'd like to recognize. Here I have just an array that has all. And then we call recognition.detectFaces that passes in the parameters. And then once that data comes back, we stringify it, and then we set the callback passing in the data as the returned stringified data. So if we look at that data structure that's returned, it's an object with the data parameter, and you'll see that that kind of maps over to what our schema looks like. So let's go ahead and take a look at this demo. Let's see here. How can we test this out? So what I'll do is I guess I'll toggle the camera. And this is going to say I'm like 25 probably. Oh, 39. Wow. Yeah. That's totally off. So we basically get the number of people, the age estimate. I'm actually going to be turning 39 in January, so that's pretty close. We have our gender, smiling. That's not right. I'm kind of smiling a little bit. Beard, no. Mustache, no. Glasses, no. Eyes open, yes. Mouth open, no. So it's, surprised, fear, yeah. It's kind of gotten some of those things right, I guess. We could also, choose a file and like upload an image or something like that, but I'm not going to worry about that. But that's kind of the idea here. And yeah, that's kind of it on that one. So now I'm going to go ahead and jump to the next one. The next thing we'll look at is real-time collaborative Markdown. So a lot of the use cases behind GraphQL with our customers and the people that I've worked with have this sweet combination of collaboration and real time. So that's kind of the main use case, right? But behind a lot of the real-time apps, it's some type of collaboration, whether that's chatting or talking or working on something. You want to be able to kind of like work in real time and see things change as people work on them. So a lot of the stuff we do has to do with collaboration. And that sits perfectly with GraphQL subscriptions. So the idea here would be to have an image editor, not image editor, a text editor, or a document editor similar to Google Docs, where people can kind of like work together on a document. So how could we create that in GraphQL? Well, the idea that I had was using Markdown, and Markdown is something that we all love to use as developers, and it's pretty easy to work with because essentially Markdown is just a big string of data or a combination of strings of data, and it has our own syntax, and then we can like parse that and render it. So I used React Markdown to kind of be the renderer on the React on the front end, and all React Markdown takes in is a string of Markdown, and then it renders that to your screen. So it's pretty simple. So that's the client piece. For the back end, I created a type of post. We have a title for the post. We have some Markdown, which is our string of Markdown. Then again, we have our ID and client ID, and then we have a created ad. The created ad is to kind of do some type of conflict resolution. So if you have multiple people working on stuff, you want to know, who made the latest change and deal with that type of stuff. As far as the operations are concerned, we have a way to list all of the posts. We have a way to get a single post. We also have a way to create and update a post. And then we have a subscription for on update and on delete posts. So let's take a look at this demo. This demo is actually collaborative in the sense that you can go to writewithme.dev and try it out. I'm going to go ahead and create a post called React Delphia. And here we're going to go ahead and open another window. And I'm going to use this image here to kind of show you how we can do some collaboration. So I'm going to go here. I want to go ahead and edit this document. So I want to go ahead and put my image here. And we'll see that in real time it's coming through on the other end. And then maybe we want to write some code. I don't know, right? I don't know. I'm just writing stuff. But anyway, that's the idea. And then I can come over here and edit stuff. And it's coming through in real time. So yeah, that's kind of it on that one. I'm going to show you the code for all of this when we're done. I have a GitHub repo with all this stuff in there, if anyone's interested. The next idea was real-time music collaboration. And this kind of really didn't come out from a customer need. This came out more from a real-time use case that we were working on that had a similar idea around a sequence of events that happens. And we need to populate and exist in a consistent client that doesn't change in the sequence based on the things that are happening on the back end. And this worked perfectly with a step sequencer in music. And that is what I'm going to kind of show you here. So the first thing I wanted to do was find a music thing to work with that was a step sequencer. And luckily, Ken Wheeler created something called TrapLord 9000. And TrapLord 9000 is a step sequencer written in React. And that's kind of what I used as the base of this project. Thanks, Ken. And what it basically does is it contains an array, or I'm sorry, a series of arrays, and each item in the array represents a step in the sequence of steps. And if it's set to 0, that means the music is not playing or the beat is not playing. If it's set to 1, that means it is playing. And if it's set to 2, that means it's kind of like a triple beat based on his implementation of this. So we can start off with this basic data model, and then you can imagine what we're going to do with it. We're basically going to stringify this again and send it across the wire as a GraphQL operation. So for the GraphQL type, we have a drum machine that has an ID, a client ID. It has the name of the drum machine, and it has the beats that are then stringified. This object is stringified and sent to the database as the beats. So what we can do then is create a subscription. When someone updates a drum machine, we can then take those beats and then render them across all of the clients that are listening. And for the queries and mutations, we have a query for getting a single drum machine. We have a query for listing all of the drum machines. So this way we can have a list of all drum machines. People can create a new drum machine, and then they can also fetch a single drum machine. And then, of course, they can update a drum machine by clicking on one of these beats and changing the items in that sequence. So let's take a look at this demo. And if you're following me on Twitter, you've probably seen this one before. It's HighBeats, and it's at HighBeats.dev. So we'll do the same thing that we did earlier. We'll go ahead and open a new window, and I'll create a new drum machine. This one is called RenderATL. I'm not sure if sound is connected there off of my computer.
Are you on a MacBook or a Windows machine?
I'm on a MacBook.
You're on a MacBook. When you shared your screen, there was a little checkbox in the bottom left that says share computer sound. So if you want to stop sharing your screen and reshare it, you could check if that checkbox is clicked.
Okay, yeah. Let me check that out real quick. Share now. So yeah, what I want to do now is set some steps along with this step sequencer, and we'll try it out. That's kind of the idea. So the idea is basically to take that, make it collaborative. That's kind of the whole idea there. And if you want to play with that, you can go to HighBeats.dev. So the next thing I'm going to look at is a new idea, I think, that people in the GraphQL community or the front-end space might not be too familiar with. And it's the idea of infrastructure as code. And this is something that we're kind of starting to really explore, and we're going to be building upon this, I think, over the next year, because it's super powerful. And I think it's kind of hard to reach if you're a front end or just even a back end developer that's not familiar with cloud computing, because there's this idea of something like CloudFormation or Terraform or even serverless framework, where you have these huge configuration files that can sometimes be 2,000, 3,000, 4,000 lines long, no joke, or even longer. And you basically use a command line or some CI/CD process to kind of upload these, and they deploy cloud infrastructure. Now, for us, I don't like the idea of any configuration files. It's not very cool for me. It's not very fun for me. But I am familiar with writing GraphQL schemas. I am familiar with a command line interface. And that's kind of what we've done. We've built a way to create and modify GraphQL or infrastructure as code using a command line and using GraphQL. So we'll take a look at how that works. And this kind of goes back to a conference talk that I gave at Chain React, where we talked about how I helped them add a real-time chat feature to the conference app for Chain React. And what we ended up doing was just taking the 2018 version of the app, getting a 2019 version by copying it essentially, and taking out their existing backend implementation and replacing it with AppSync with GraphQL. And then we added a discussion tab where people could like create different comments and talk about an individual talk, and you can kind of see those comments come through in real time. So we built this app. Everyone liked it. We deployed it, had it ready for the conference and everything like that. And while we were building it, I was really enjoying the process, and I thought about maybe making this reusable for other people. And then after I actually gave the talk, a bunch of people asked me, how can we like do the same thing for their event, essentially. So what I ended up doing was creating a project called Conference App in a Box. And I actually did a live stream on this today, and I'm going to show kind of how this looks. But what it basically is it's a conference app front end and a conference app back end. And the back end is built using Amplify and using GraphQL and kind of using this idea of infrastructure as code. And I'm going to kind of like show you how that works. But in the past, it's very familiar for us as front-end developers to clone a project, run npm start, and maybe hit a open API endpoint, or maybe hit or work with some local data, right? But the idea of deploying not only the front end but also the back end is kind of like not that. I don't think we've ever done a lot of that, right? Because when you're talking about a back end, you have to take a lot of things into consideration. You have to think of the data model, first of all, and that's usually the thing that you have to really worry about for to do something reproducible. Not only do you have to have the data model right, you have to have authentication and authorization and data access patterns. All of that has to be done right. And you have to have a way to actually deploy it in a reproducible manner. And the only way to really do that, I think, these days is with infrastructure as code. So with the Amplify CLI, you can actually create this infrastructure as code underneath the hood without actually having to deal with it or worry about it. And we're going to take a look at what that looks like. But before we get into that, for the conference app, we needed two main types. We needed a type for a talk and a type for a comment. The talk type contains all of the information about each individual talk. So it might contain a location, a name, a speaker bio, maybe even the Twitter and the GitHub handle of the speaker, whatever metadata about the talk needs to be there. And then we create a comment for each talk. So we need a comment type. And then we need to create a relationship between a talk and a comment, because you want a person to be able to comment on a talk. So you have to have some type of relationship there. So to build this and to kind of have the reusable infrastructure as code, Amplify actually builds all this for you and puts it in the Amplify folder. So to start it off, I just basically created a brand new React Native project, initialized a new Amplify app, added the API. I used a similar schema to that I used in the Chain React app. And then I added also authentication, and then I ran Amplify push, and that kind of deployed the backend. After the backend was deployed, I just wrote the front end, just kind of styled it, whatever, the way I wanted it to look. And then I open sourced it on GitHub, and in the GitHub folder, you can kind of, or in the GitHub repo, you can go check it out. You have this Amplify folder that contains a backend folder. And then the backend folder, you have two different services. One is for auth and one is for API. The API has all of the GraphQL and infrastructure that you need for AWS kind of there. And you have your GraphQL schema, you have your resolvers, you have all that stuff. And you don't really need to do anything other than modify your schema to be whatever you want. And then you can like change that by running Amplify push. And let's take a look at what you get out of that. Recently, I worked with some people from RenderATL. And what we end up doing is kind of like building a version of their app using this conference app in a box. So that's what we're going to take a look at real quick. So I'm going to go ahead and say, go to conference app in a box. And we'll take a look at the repo real quick.
Shouts out to RenderATL. I can't wait for it.
Yes, me too. It's going to be awesome. So this is the repo if you're interested in playing around with it. This is the Amplify folder that I was talking about right here. This has the backend, which has authentication and API. And when you run this, you can just run these commands here. You clone the app, npm install, amplify init, and amplify push. That deploys the backend and of course, you already have the front end. And then to run the app is React Native Run iOS. So what I want to do is go ahead and test this out, and I want to show you kind of how this looks and how you might modify it. So I'm going to go ahead and sign in real quick. I might need to sign up first, actually. There we go now. Okay, cool. So this is the way that we kind of themed this yesterday for RenderATL, because they have like this black and pink color scheme going on. But let's say that React Adelphia like wanted to throw a conference. What's your website name, or do you have a website?
We are in the process of making one.
What's a
we
good
don't have one currently?
Yeah, well, okay. Let's look at React Advanced. There we go. I see React Advanced. I think I tried this one once anyway. So what if we wanted to kind of like copy React Advanced though? What I would do would go ahead and open up. I'm gonna go ahead and open up this conference app in a box in my code editor, and I'm gonna go ahead and show you how to theme it, and we'll go ahead and add some data, and then we should be done. This should only take maybe just a couple of minutes. So for the theme, we have this theme file. Try to zoom in as much as I can. And the theme file has the logo, it has the dimensions, it has your primary and your secondary colors. So for React Advanced, it looks like they have this cool green color going on here. So let's go ahead and see if we can't find a way to copy that in some way. So there we go. So let's copy this green color. That's going to be our highlight color. And then we want to maybe copy their logo, something like that. This might look kind of ugly because we have a dark color scheme, but they have a white background. But we'll see how it looks. So first of all, we've gone ahead and changed the color scheme to be green. Now let's go ahead and swap out that logo. So what I'm going to do is open up my desktop and grab that screenshot I just took. And I'm going to go ahead and update the assets to have RNAD, I guess, .png. And then we're just going to import from rnad.png. And now we're going to have a really ugly logo, but at least we're going to have our React Advanced logo. All right. So why is it blue? Oh, I think because I think when I took the screenshot, let me try that one more time.
You've officially made me know that I have to get a website up now.
That's all good. So, okay, there we go. So let's try that one more time. Okay, that's a little better. So we have the React Native Advanced, and let's take a look at the. So if we drill down into a talk, we see that we can like discuss it. So let's simulate a discussion. So from the project, after you've cloned it, you can just run amplify console API, and this will go ahead and open up the GraphQL API in your dashboard. And also need to open up one more thing here. Okay, so I'm going to go ahead and choose GraphQL there. That's going to open up that. And while that's happening, I need to get the client ID to log in using my Dabit 3 username that I just used a second ago. We basically went away to simulate the client. Oh, it looks like I'm already logged in. That's good. Okay, so what we're going to do is let's go ahead and list the talks. And what we want to do is find this let's simplify your complex form. So there we go. We have that ID. So we can create a comment on that ID by just passing in this ID. And I'm going to say React Delphia. And then created by Dabit3. And there we go. We see that the comment came through in real time. And all of that can be deployed, again, like using that infrastructure as code in like just, I don't know, 30 minutes. I think we did it earlier on the screencast on Twitch. So it's pretty cool. All right, so that's really about it. The idea behind this talk is the combination of GraphQL and React, and then taking advantage of managed services in general, like a lot of these AI services and stuff. You can do quite a bit without a lot of work and without a lot of code. If you want to see the code for all of these apps and more, I think I have 9 different apps here now. You can go to Dabit3/Curious Cases of GraphQL. And then I also have an SMS chat where you basically can text message Markdown to a phone number, and then it comes to in real time on like a UI for like interactive demos and for conferences, really, like if you want to like have people participate in the talk. Again, follow me on Twitter, Dabit3, GitHub, and Medium. And the people that I had used their artwork for this off of Unsplash are Jens Johnson, Kareem Mandra, Christian Spies, and Edward Andrade. Thank you for that. And that's about it. Thank you. Oops.
Thanks, Nader. So we have Jason from Gatsby coming up next. He's on the line right now, but I was wondering, Nader, would you have time to answer 1 or 2 questions real quick?
Yeah, please.
So if you have a question, just raise your hand. One of us will run over to you and give you a mic so Nader can hear you. And then we'll move on and talk to Jason and do the same.
So I actually have a question. So I know you do a lot of work with Amplify. Is there a specific way in which Amplify is using the client, or is there a way to query data with Amplify using a different client-side library?
Yeah, so we have 2 different GraphQL clients that kind of work first class with our authorization mechanisms. One of them is the Amplify client, of course, and then we have an AWS AppSync JavaScript SDK, which is essentially we forked some of the existing Apollo implementation and added a few new features. And that way you can still use like a React Apollo and all that. So you could use one or the other there, but a lot of people are using things like Relay and just Apollo. So you're not really tied to any client, but using some of the AWS clients, the Amplify and AppSync clients, takes care of some of the work when you start doing things around authorization and authentication.
Oh, awesome. Yeah, that's actually something I was specifically wondering about was with Apollo. So thank you.
I have a question.
Okay.
Did it hurt your feelings when the recognition API didn't think you were 25?
Well, it's not bad because I've gotten like 43 before, so I'll take 39.
Awesome. Nader, thank you so much for joining us. I really appreciate having you, man.
Thanks for having me. Yeah, it's been great.
Awesome. Talk to you soon, man.
Nader.